Let's review u substitution. This is from a practice worksheet that we worked on in class. This is number 5. This is an indefinite integral because it does not have the lower and upper limits of integration. And what the indefinite integral basically tells us to do is to find the antiderivative of the integrand. And the dx, you can just think of that for now as announcing to us that the variable is x. Now, we're going to be doing u substitution with this because when we look at this integrand, we don't just know the antiderivative. If we had, for example, the indefinite integral of x squared dx, we can just reverse the power rule and we know that answer. So we go ahead and just find the antiderivative. If we had something like 4 sine x dx, we know the antiderivative of sine is going to be cosine, but negative. And then the constant multiple just hangs out. So this is one we can just do in our heads. If we can find an antiderivative in our head, then we go ahead and do that. If anything is more complicated, you're going to be doing u substitution. That's pretty much the only other method we learned this year. And u substitution is used to undo a composition. So what we want to do with the integrand is we want to look for an inner function. So we want to look for a function that is often inside of parentheses. Maybe sometimes there's an exponent, sometimes inside of a square root. Sometimes it'll be the denominator of a fraction. In this case, it's up here in the exponent. So if we look at 7x times e to the 5x squared, e to the 5x squared is an exponential function where you have a 5x squared inside. So 5x squared is going to be our inner function. And so what we have is e to this inner function. And then we have these extra parts of the expression, 7x. Those are going to come into play later. So we'll see how to handle those in just a moment. And what you do once you found your inner function is you find the derivative with respect to the variable of both sides. So we're going to find the derivative with respect to x of both sides, which is going to be 10x. And then we want to isolate the du. So I'm going to move the dx to the other side. Now, when you look at this expression, we have 10x dx. And if you notice, we have a dx here. And we also have an x. That was part of the extra stuff we haven't used yet. But we don't have a 10, but we do have a 7 that we don't want. So to figure out how to handle this, the first thing I'm going to do is I notice that the 7 here is a constant multiple. So what I'm going to do with that constant multiple is just move him out to the front, because anytime you have a constant multiple, you can just move that in front of the integral, because that's one of our properties of integrals. And then now I have the x and the dx. So let me just go ahead and put those next to each other. I'm going to use the commutative property. So I'm just going to put the exponential function first times x dx. So I have x dx. If this 10 wasn't in the way, then I could make a replacement. So there's a few different ways to handle this. The way that I encourage you to use is, since you have x dx and x dx here, let's just move 10 to the other side. So if we divide by 10 or multiply by 1/10, then I have a new equivalency of 1/10 du equals x dx. So what that's going to allow me to do is replace x dx with 1/10 du. So the constant multiple stays out front. And what we're going to do now is get rid of all of our x's and replace with expressions involving u. So instead of e to the 5x squared, we're going to replace 5x squared with u. And instead of x dx, we're going to replace x dx with 1/10 du. That 1/10 is a constant multiple, so I'm going to move that out to the front. It's nice to move the constant multiples out front because they get out of your way. And now what we have for the integrand is something much simpler. We may not like the variable u as much as we like the variable x, but this is definitely an easier thing to integrate. So what we can do now is we can actually find the value of the antiderivative. Notice I kept the integral symbol this whole time. Now I'm going to go ahead and I'm going to find the antiderivative of e to the u. The antiderivative of e to the u is e to the u. And then I'm going to put the plus c, because when you have an indefinite integral, you want to use the plus c. And then my final step is to go ahead and put the expression for u back in. So we want to get u out and put x back in. And this should be our answer. You can always check your answer by finding the derivative. So if we find the derivative of this function, the 7/10 is a constant multiple that's going to hang out front. The derivative of e to the 5x squared is e to the 5x squared. You make a copy. That's how you handle the derivative of e to the power. And then because of the chain rule, we'll have to multiply by the derivative of the inner function. And then the derivative of c, that's a constant, that's going to be 0. So I have 7/10 in my check. And then the derivative of the inner function is 10x. And what's going to happen here is 10 over 10 reduces. We end up with 7 times x times e to the 5x squared, which is exactly the same as the integrand we started with. That's how I know we did it correctly. This matches the original integrand. Now, I want to go ahead and do a second example from that same practice worksheet in class, and it's number 1. And the reason I want to go back to this one is to remind you that when you have, so first of all, you want to look and ask yourself, do you just know the antiderivative? Not quite. But you do see a composition, I hope. You see that you have a sign and you have an expression inside. And if you notice, that inner function is linear. So whenever you have an inner function that's linear, you have a shortcut you can use. Use substitution will still work, but the shortcut's going to be quicker. So let me actually go ahead and just move the constant multiple out front. The 8's kind of in the way. So let me move that out front. And now because the inner function is linear, the shortcut that we can use is we can go ahead and just find the antiderivative of the outer function, which will be negative cosine. Keep the inner function the same. And then what we have to do is multiply by the reciprocal of the coefficient of x. What we're really doing there is dividing by the derivative of this because we're undoing the chain rule. But the way I like to think of it is multiply. If you have an inner function that's linear, multiply by the reciprocal of the coefficient of x. Don't forget your plus c. If you're doing a free response on the AP exam, you can leave it just like this. But we can go ahead and simplify that. 8 times 1/4 is going to be 2. I'm going to slide the negative out to the front. And I clean that up a little bit. And if you find the derivative of this, it does match the integrand. Now, just to remind you, u sub does work. It's just going to take longer. So let me go ahead and move the 8 out front. And let's have u be equal to the inner function. When you find the derivative with respect to x, you get 4. Slide the dx to the other side. There's a few different ways to handle this. I went ahead and moved the 8 out front. I could have left it in and kind of factored it, made it 4 times 2, but I'm just going to continue this way. So I'm going to keep the 8 out front. And then if you notice, I don't have a 4 inside. So what I'm going to do is move the 1/4, move the 4 to the other side, making it 1/4, so I can replace dx with 1/4 du. So now that I'm ready for my substitutions, I'm going to keep sign, replace 4x minus 1 with u. I don't need the parentheses. I just decided to write them. I'm going to replace dx with 1/4 du. I'm going to move the 1/4 out to the front. That's going to make 2 when I simplify, because it's 8 times 1/4. And notice I've kept this integral symbol the entire time because I haven't actually found the antiderivative yet. Now I'm ready to find the antiderivative of sine. That's cosine. Don't forget the plus c. And your final step, if you're doing a u substitution, is to get u out of the problem and put the expression with x back into the problem. We do get the same answer. But if you have an inner function that's linear, the shortcut is definitely quicker. If you catch it, oops, I made a sign error. The antiderivative of sine is negative cosine. If the composition has an inner function that's linear, the shortcut is definitely the way to go. But if you ever accidentally don't catch it, that you can use the shortcut, the u substitution will work.